Hello and welcome to today's class. For today's class, we're dealing with combination, and by definition, combination simply tells us the number of ways of selection of some particular items taking a particular number at a time. All right. So combination has to do with selection. The selection of n number of items taking r at a time is given by n combination r. And for combination, the numerical value is equal to n factorial all over n minus r factorial r factorial. So this is how we express combination. For instance, if I have this evaluate let's say 100 combination 98, for instance, this will be equal to this as 100 factorial all over this minus this 100 minus 98 factorial, and then this one again there, that's 98 factorial. If I should work on this now, this will be equal to 100 factorial is same thing as 100 times 98 factorial all over this becomes 100 minus 98 gives you 2 factorial, and then I have this one here times 98 factorial. So I stopped here because I'm expecting that this value will cancel this. We explained this in the last class when we talked about permutation. All right. So if you missed the class on permutation, simply check the description of this video. I'll share a link on how to watch our previous class on permutation. All right. After this, so from here, this can now cancel this. So that's equal to 100. 2 factorial is 2 times 1, which is 2. So that's equal to 100 all over 2. And therefore, our answer is equal to 50, 50 as our answer. So therefore, 100 combination 98 is equal to 50. So this is how we do solve problems on combination. All right, so let's look at the second example. Now, this question says, how many different sets of 4 students can be chosen out of 17 students to contest in a mathematical quiz? So for what I have here, my total number of students, n, is equal to 17. I'm choosing 4 at a time. That means r is equal to 4. So hence, n combination r will be equal to 17 combination 4. So if I had to solve this now, this will now be equal to this one factorial 17 factorial all over this minus this 17 minus 4 factorial, and then this one here, that's 4 factorial. So work on this. This is equal to 17. If I do 17 minus 4, I'll have 13. So I'll stop at 13 factorial. So 17 times 16 times 15 times 14 times 13 factorial all over 17 minus 4. I have 13 factorial multiplying 4 factorial. From here, 13 factorial will cancel 13 factorial. That will be equal to 17 times 16 times 15 times 14 all over 4 factorial is 4 times 3 times 2 times 1. So this is equal to, so let's look at this, 17 times 16 times 15 times 14, 57, 120 is my answer, all over 4 times 3, 12 times 2, 24 times 1, 24. 4 factorial is 24. So this all over 24, my answer is 2380. I said how many different sets? So 2380 different sets. All right, so my answer is 2380 sets. So this is how we solve simple ideas, or this is how combination works. Next up, let's look at the algebra of combination. All right, so let's look at this question here. This question says that show that n combination r is equal to n combination n minus r. So show that these two are equal. How do we do this? The task would be, you can either choose this one out and simplify this. If it gives you this answer, it means they are equal. So how do we solve this? This one first, I have n combination r. This is equal to, from what we know, it's n factorial all over this minus this, n minus r factorial, and then this one here, and then r factorial. All right, let's get for this now. This one here would have n combination n minus r. What do we get there? That's equal to this one first. That's n factorial all over this minus this. So n minus r, all of this factorial, and then this factorial, and then n minus r factorial. Don't forget, is this first, this factorial, n factorial, divided by this minus this. So it becomes n minus, in bracket, all of this, then factorial, and then this one here, this factorial. If I simplify this is equal to, I'm having n factorial all over, take off this bracket here, becomes here, this is n, minus to this becomes minus n, minus minus gives you plus r, and then factorial. So n minus to this minus n, minus minus is plus r factorial, and then this one here, n minus r factorial. So I have this. From here, n minus n will cancel out, so it's off. So this is now equal to, I'm left with n factorial all over, this becomes, I'm left with just plus r, that's r factorial into n minus r factorial. I can still rewrite this as being equal to n factorial all over this one first, n minus r factorial, and then this one here, r factorial. So observe that this answer and this one are the same thing. So you can now say, therefore, n combination r is equal to n combination n minus r. So hence, we've proven this to be true. So this is how you prove this algebra of commutation, of combination. This algebra of combination. All right, so let's look at this question that combines the idea of combination and permutation together. It says if 30 multiplying n combination 5 is equal to n permutation 4, find n. That's it. So let's work on this. So this becomes, that becomes 30 multiplying combination. We said this is n factorial. So it becomes 30 times n factorial all over n combination 5 is n factorial all over n minus 5 factorial, 5 factorial is equal to, for permutation. Now remember how we do permutation. For permutation, this becomes n factorial all over n minus 4 factorial. So I have this. All right, so let's work on this. This will be equal to 30 times this gives you 30 n factorial all over. This gives you n minus 5 factorial. 5 factorial is equal to, this becomes n factorial all over n minus 4 factorial. So we have this. So work on this. Now this is equal to, I'll keep reducing this one here until I get to n minus 5. So that becomes 30. I have n. Reduce this by 1, it becomes n minus 1. Reduce by 2, by 1 again becomes n minus 2. Reduce by 1 again becomes n minus 3. Then again, n minus 4. Of course, you're stopping at 5. Okay, I need space there. All right, so let's get this. This is n factorial. I'll keep reducing this one here until I get to n minus 5 factorial. So that's equal to, I have 30 into n, and then n minus 1, and then n minus 2, and then n minus 3, and then n minus 4, and then n minus 5 factorial. So I have this, okay, all over. I have here as n minus 5 factorial, then 5 factorial is equal to, for this one here, I'll keep reducing this one here until I have n minus 4 factorial. That will be equal to n, remove 1, I have n minus 1, just continue going backwards, n minus 2, and then n minus 3, then finally n minus 4 factorial. I have this one here, all over n minus 4 factorial. So I have this. All right, so what can cancel out from here? N minus 5 factorial can cancel n minus 5 factorial. Also, n minus 4 factorial here can cancel n minus 4 factorial here. So we said if you have the same terms on both sides of the equation, they can cancel out. So hence, n here can cancel n here. Also, n minus 1 here can cancel n minus 1 here. Same thing for 2, n minus 2 and n minus 3 here can cancel n minus 2 and n minus 3 here. So what's left here is 1 all over 1 after all cancellations. So this is now equal to, here I'm left with 30 into this one here, m minus 4 all over 5 factorial. Let's punch 5 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. The value is 120 is equal to 1 over 1 gives you 1. All right. The lowest term there, 30 here, 1. 30 here, that will give you 4. So I now have that, n minus 4 all over 4 is equal to 1. The tax will be, of course, 1 over 1. So cross multiply this times this. So I have n minus 4 times 1 is equal to 4 times 1. So I have n minus 4 times 1 is n minus 4 is equal to 4 times 1 is 4. So n is equal to 4. Minus 4 comes and becomes plus 4. So n is equal to 4 plus 4. That's 8. So the value for n is 8. So this is how we solve this question. So let's look at another question in combination. It says find n if 4n combination 2 is equal to n plus 2 combination 3. So quite easy. So this becomes here from this one, I have 4 times, let's evaluate this. This becomes n factorial all over n minus 2. So n minus 2 factorial. Then this one here, 2 factorial is equal to evaluate this, it becomes n plus 2 factorial all over this minus this, n plus 2 minus 3 factorial, then this one here, 3 factorial. So I have this. All right. So this becomes 4 times n factorial gives you 4n factorial all over this n minus 2 factorial 2 factorial is equal to, this one gives you n plus 2 factorial all over n. 2 minus 3 is minus 1 factorial, and then this one here 3 factorial. All right, so let's see how we can work on this. To work on this one here, so we have to reduce this one here till it gets to n minus 2, so you can cancel out. Same thing here. So this one becomes 4n into, reduce this becomes n minus 1. Reduce it again becomes n minus 2 factorial all over n minus 2 factorial 2 factorial is equal to, reduce this one here until it gets to n minus 1. So that will be n plus 2 first, subtract 1, it becomes n plus 2 minus 1, which is n plus 1. Subtract 1 again, it becomes n plus 1 minus 1, that's n. Subtract 1 again, it becomes n minus 1 factorial all over n minus 1 factorial, and then 3 factorial. So we have this. All right, so from here now we can see that n minus 2 factorial will cancel n minus 2 factorial. n minus 1 factorial will cancel n minus 1 factorial. And what's left? I can see n here. So n here can cancel n here. And that's about all. Okay. So from here I have 4 into n minus 1 all over 2 factorial is equal to, this one gives me n plus 2 into n plus 1 all over 3 factorial. So it depends on how you want to solve this. You can choose to cross multiply here. It's still okay. So this one here becomes 4 times 3 factorial times, in bracket, n minus 1. So all of this times this, 4 times 3 factorial times n minus 1 is equal to this times this, 2 factorial multiplying n plus 2 multiplying n plus 1. So I have this. So this gives me 4 times 3 factorial is 3 times 2, which is 6, times 1 of course, which is 6, multiplying n minus 1 is equal to 2 factorial is 2 times 1, which is 2, multiplying n plus 2 multiplying n plus 1. So we have this. So 6 times 4 is 24 into n minus 1 is equal to 2. If I expand this, n times n is n squared, n times 1 is plus n times 2 times n is 2n plus 2 times 1 is 2. So I have this. All right, collect like terms, simplify. 24 times n is 24n minus 24 times 1 is 24 is equal to, this is 2. So if I look at this, this is n plus 2n. If I sum this, you have 3n. So this one will give me plus, combine these two, I have 3n plus 2. So 2 times n squared gives you 2n squared plus 2 times 3n gives you 6n plus 2 times 2 gives you 4. So I have this. All right. So simply move everything over here. So this becomes 0 is equal to 2n squared plus 6n plus 4. This one comes over here, becomes minus 24n. Minus 24 come over here, becomes plus 24. So I have this. So hence 0 is equal to 2n squared, 6 minus 24, that gives you minus 18n, 4 plus 24, that's plus 28. So you now have to simply solve this quadratic equation. I think we've already studied how to solve quadratic equation already. I'll leave a link to quadratic equation in the description of this video. So I'll just go straight to getting, okay, to get your final answer, you can simply choose to divide through by 2. Since 2 is common here, divide here by 2, divide here by 2, divide here by 2, divide here by 2. So I'll have that 0 is equal to, here will be n squared minus 18 over 2 is 9n plus 28 over 2 is 14. Two numbers that will add up to give minus 9 and multiply to give 14. That's n, that is minus 7 and minus 2. Minus 7 minus 2 gives you minus 9. Minus 7 times minus 2 gives you plus 14. So I'm having n minus 7 or n minus 2 is equal to 0. So this would mean that from here, I'll have that n minus 7 is equal to 0. So n is equal to 7. Or, so minus 7 comes here, becomes plus 7. Or, for this one, I have n minus 2 equal to 0. Move this over here, I'll have n is equal to 2. So n is equal to 7 or 2. But here's the thing, we know that in combination, we expect that if I have n combination r, I expect that the value of n should be greater than r. So if I look at this, r in this case is 3. So my value, or r in this case is 3. So I expect that my value should be bigger than 3. If I look at this, between 7 and 2, it is 7 that is bigger than 3. So we say n cannot be 2. So therefore, n is equal to 7. All right. So that's how we solve this problem. All right, let's try a final example on this. So this question says, find n if 5n permutation 3 is equal to 24n combination 4. Find n. Okay, so for this one here, this is 5 times this one. For permutation, I have n factorial all over n minus 3 factorial. Now this is permutation. Is equal to, for this I have 24 times, I have this n factorial all over n minus 4 factorial. And don't forget, it's combination. I'll repeat this one. So it becomes 4 factorial. So I have this. All right. So I'll show you an even faster method of solving questions on combination. And the idea is this. If I have the same term on both sides of the equation, they can cancel out easily. So that's me saying that n factorial can cancel n factorial here. I'm having 1. I'm having 1. So this becomes 5 times 1. That's 5 all over n minus 3 factorial is equal to 24 times 1 is 24 all over n minus 4 factorial 4 factorial. So observe that I didn't have to wait to start reducing this one first to cancel this. No, you can cancel like this directly. It's still mathematically correct. Next up, I'm seeing n minus 3. I'm seeing n minus 4. I think one of these can cancel out. That's this one here. This is n minus 3. If I subtract 1, it becomes n minus 4 factorial, which can cancel this one. So I'll be having 5 all over. This becomes n minus 3. Subtract 1 becomes n minus 4 factorial. So this is equal to 24 all over. I'm having n minus 4 factorial and then 4 factorial. So this is so, I'm having the same thing, n minus 4, on the same part of both sides of the equation, which is denominator, denominator. So this one can cancel this one here. So I'm left with 5 all over n minus 3 is equal to 24 all over 4 factorial is 4 times 3, that's 12 times 2, that's 24. So that's still 24, the same thing. Okay, so this is so, this here 1, this here 1. So hence, I have that 5 all over n minus 3 is equal to 1 all over 1. This multiplies this, this multiplies this. So 1 times n minus 3 is itself. So n minus 3 is equal to 5 times 1 is 5. So I have 5. So get n. N is equal to 5. Minus 3 comes, it becomes plus 3. 3 plus 5. 5 plus 3 gives you 8. So hence, n is equal to 8. This is how we solve this problem.